solution 2. In the previous day I have discussed about the solution 1, that is the vapor pressure of the pure solvent and that of a solution. And the vapor pressure of a pure solvent is higher than that of the vapor pressure of a solution. It was discussed in the earlier class. Now today I have to discuss about the colligative property of solution. What is the colligative property? You know, the colligative property is the property which depends only on the number of moles or the number of particles of the solute dissolved in a solvent. This is the colligative property. Only it depends on the number of particles of a solute. And the colligative property, it does not depend on the nature of the solvent, only depends on the number of particles of the solute. There are 4 colligative properties, and the first is the relative lowering of vapor pressure, second is the elevation of boiling point, third is the depression of freezing point, and fourth is the osmotic pressure. Now I have to discuss about the first colligative property, that is the relative lowering of vapor pressure. The vapor pressure of a pure solvent at certain temperature is higher than that of its solution. If in a pure solvent a solute is dissolved, then the vapor pressure of a solution is decreased. It has been discussed in the earlier class. Now if we assume the vapor pressure of a pure solvent is P0 and the vapor pressure of its solution is P, where P0 is greater than P. And it can be explained by a law. This law is known as the Raoult's law. The Raoult's law states that for a non-volatile, non-electrolyte solid, the relative lowering of vapor pressure of a solution is equal to the mole fraction of the solid present in a solution. This is the Raoult's law. Now if the vapor pressure of a pure solvent is P0 and the vapor pressure of a solution is P, then vapor pressure of the solution is lowered by P0 minus P, that is delta P. This is the difference of vapor pressure. P0 is greater than P. Now the difference is P0 minus P equal to delta P. This is the vapor pressure which is lowered. This is the lowered vapor pressure. Now the relative lowering of vapor pressure. The relative lowering of vapor pressure equal to P0 minus P by P0. This is the relative lowering of vapor pressure. And according to the law, according to the Raoult's law, the relative lowering of vapor pressure is equal to the mole fraction of the solute present in the solution. So according to the rule, P0 minus P by P0 equal to X2. X2 is the mole fraction of solute. Mole fraction of solute, where X1 plus X2 equal to 1. X1 is the mole fraction of the solvent, X2 is the mole fraction of the solute, and the summation is equal to always 1. This is for the binary solution. And from this equation, we can determine the molecular weight of the solute and the molarity of a solution. This law is only applicable for the dilute solution. There is very dilute solution, and this law is only applicable for the non-electrolyte, non-volatile solute, and the solute which does not dissociate or does not associate or dissociative or associative solute does not obey the rule. So it is only applicable for the non-electrolytes and non-volatile solid. This is the Raoult's law of the relative lowering of vapor pressure. And from this vapor pressure, from this law, we can determine the molecular weight of a solid. Now let us look. According to the rule, we may write P naught minus P by P naught equal to X2, where P naught is the vapor pressure of pure solvent, P is the vapor pressure of the solution, and P naught is the vapor pressure of the solvent, and X2 is the mole fraction of the solid. But this law does not depend on the temperature, because this is the relative case, this is the relative matter, so it does not depend on the temperature. This is temperature independent. Now X2 is N2 by N1 plus N2, where N1 is the number of moles of solvent, N2 is the number of moles of solid. Now if the solution is very dilute, then for dilute solution, N1 plus N2 is nearly equal to N1. For dilute solution, the number of particles or number of moles of solute is very low. So N1 is very high than N2. It is very higher than N2. That is, N1 plus N2 is nearly equal to N1. Most of the particles of the solution is nearly equal to N1. Then P naught minus P by P naught equal to N2 by N1. This is for dilute solution. N2 by N1. N2 means W2 by M2, that is weight of the solid by the molecular weight of the solid. By W1 by M1. W1 is the weight of the solvent, M1 is the molecular weight of the solvent, is equal to W2 M1 by M2 W1, or M2 is equal to W2 by W1 into P naught by P naught minus P into M1. This is the molecular weight we can determine from this equation. M2 is the molecular weight of the solid, W2 is the weight of solute, W1 is the weight of solvent, P naught is the vapor pressure of pure solvent, P is the vapor pressure of solution, and M1 is the molecular weight of solvent. From this equation we can determine M2, that is molecular weight of solute. Molecular weight of solute. This is how we can determine the molecular weight. Now we have to determine the molarity of a solution. The molarity of a solution. According to the law, we can write P naught minus P by P naught equal to X2 N2 by N1 plus N2 is equal to N2 by N1, that is for dilute solution. And now N2 P naught minus P by P naught is equal to N2 by W1 by M1 is equal to N2 by W1 into M1, or N2 by W1 is equal to 1 by M1 P naught minus P by P naught, or N2 by W1 into 1000 equal to 1 by M1 P naught minus P by P naught into 1000 multiplied by 1000 on both sides. Now molarity, what is the molarity? What is the molarity? Molarity is the number of moles present in 1 kilogram or 1000 gram of a solvent. Now N2 mole is dissolved in 1000 gram of solvent. 1000 gram of solvent. So 1000 gram of solvent can dissolve N2 mole. That is W1 gram solvent contains N2 mole. 1 gram solvent contains N2 by W2 mole. 1000 gram solvent contains N2 by W1 into 1000. That is 1000 gram solvent contains this mole. This is equal to M, molarity, or molarity is equal to number of moles of solute by the weight of solvent into 1000. This is the molarity. Therefore molarity is equal to 1 by M1 P naught minus P by P naught into 1000, or M, small m, equal to 1 by M1 P naught minus P by P naught into 1000. Thus we can determine the molarity of a solution if we know the molecular weight of the solvent and the vapor pressure of pure solvent and that of the solution. Then we can easily determine the molarity of a solution. This is the relative lowering of vapor pressure, and from here we can determine the molecular weight of the solute and the molarity of the solution.